I'm going to be comparing this afternoon. And welcome back from lunch. Hope you had a good one. And sorry about this morning running a little bit over, but however, those things happen. Downstairs was the same too. Claire Williams is our next speaker. And Claire is an astronomer and an assistant director of the Canberra Planetarium and Observatory. She's been studying and investigating the UFO question for 28 years. Now, the lecture this afternoon, or the talk this afternoon, is called Lesson from Sidonia, Verdict on the Face of on Mars. Claire reviews the 20-year history of the face of Mars, paying particular attention to details from the most recent flyby pictures. She discusses the implications of the latest face on Mars information for ufologists. Welcome, Claire.
Thank you very much. Now, I believe I'm going to have to handle my own overhead transparency here, so I'll just have to be ducking backwards and forwards to the overhead projector. I'd like to put up my first image.
You just show me what to do.
Yes, if you'd like to just... I've got me, yeah. It's come out well enough and that everybody can see it. Can you all see that clearly? Is that a little better? That should be okay, is it? Right. Well, this is the image that was released or taken by the Mars Global Surveyor earlier this year in April. And this, to me, is the definitive answer as to what the face on Mars actually is. And I'd like to compare this particular image to the next one, which is the original image that was taken by the Viking lander, or Viking orbiter, sorry, back in 1976. This was the one that was originally issued with a press release and is very suggestive of the face, as we can see in the centre there at the top. Now, this particular image is the one that started the whole story of the face on Mars, and really it's quite a saga in its own right. For 22 years now, people have been looking at this image, processing it through various techniques and arguing for and against the presence of a civilization on Mars. The principal evidence that they have used has been the symmetry of the face itself, and we can see, if we just go back to the previous image, that that symmetry really was a complete illusion. What we actually can see when we look closely at the face, or the maser that is the face on Mars, we see that all those structures that people thought were artificial turn out to be quite natural looking, in fact. And so we have the eye being a crater, we have the nose as a ridge, possibly showing thermal vents or hydrothermal vents, and the mouth has been identified by a geologist as a landslide caused by a process called solifluction. Now, not being a geologist myself, I can't explain the natural processes involved, but this particular geologist said that this whole thing is anomalous in itself, but not because it's an artificial structure in the wrong place, simply because it's a geological anomaly, and very interesting from that point of view. And I think that this is a point that I haven't made in my paper on it, but one that I'd like to make now, and that is that quite often when we look at images such as these, what we actually miss out on when we take it, we argue over whether or not these things are artificial, is that we lose the opportunity to study them for what they really are, as natural phenomenon, and very interesting natural phenomenon in their own right. And sometimes we overlook the most interesting natural phenomenon because we want to ascribe a paranormal explanation. If I could just have the next, the press release. This is the press release that was originally issued with that first image of taken by Viking. And you'll see there that the JPL, or Jet Propulsion Laboratory scientists, were quite circumspect in their description of the object, and I can't quite see it and I can't remember it. Just trying not to make too much noise. Okay, they've said that the picture shows eroded maser-like landforms. The huge rock formation in the centre, which resembles a human head, is formed by shadows giving the illusion of eyes, nose and mouth. The feature is 1.5 kilometres long, or across, with the sun angle at approximately 20 degrees. The speckled appearance of the image is due to bit errors emphasised by enlargement of the photo. The picture was taken on July 25th from a range of 1,873 kilometres. Viking 2 will arrive in, just goes on there to describe the schedule of Viking. But they said back then that it was a trick of the light, and a lot of people didn't believe them, and there's been this discussion raging ever since. If we could just have the next transparency. That's it. This one actually shows the... Okay. Somewhere?
For the video.
Thank you. This one actually shows the original image that was transmitted by the Viking craft, and it's the region now known as Cydonia, and the face is actually there in the image, and I'll point it out to you. I like to walk around and I feel a bit confined here. Okay. Let me see if I can remember exactly where it is. I believe that the face itself might be this landform down here, just in there. It's quite a poor quality image, and you may be able to make out across here that there's all these little black dots that run in lines across it. They're known as réseaux, and they're little markings that were actually on the faceplate of the camera. And the idea behind putting those in was so that they could determine whether or not there was any distortion of the image taken by the camera. The type of camera used is called a Vidicon, and it wasn't like our modern CCD cameras or video cameras. It was actually closer to a TV camera using the same technology. And the picture could be distorted by the presence of electromagnetic fields. So in order to be able to eliminate that sort of distortion, they needed some sort of grid, and they devised this technique of putting these little dots on the faceplate of the camera. So we have those across the image. We also see the presence of, I don't know whether you can make it out from there, but there are lots of little odd little markings within it, which are called bit errors or transmission errors. And all of these had to be removed from the raw images. I've got two raw images, the two frames that were basically used throughout the whole Mars face debate. If I could just have the next one that shows the other frame, which is 32A70 from memory. Sorry, 35A72. This one is a lower resolution image. The other one was actually the higher resolution image. This is a slightly lower resolution image taken from further away, And the face maser in this one is just about there. Once again, we can see there's one of those roseaux nearby, and all this sort of noise in the image has to be removed. We could just have the next one. Now, I don't want this to turn into a dry discussion about image processing, but there are certain issues involved that really need to be looked at and addressed before we can understand how some of the mistakes were made in the identification of various Cydonia landforms as being artificial. Here we have a close-up image of the face taken in those two Viking frames, 35 and 70, I'll refer to them as. One of them, the one on the left-hand side, shows remarkably more noise than the other one, and we can see lots of speckling there. Now, the speckling is less noticeable on 70, but you'll notice that there's a big roseau on the side of the face. Now, when you look at the processed images, you never see all that noise or the roseau. It's usually been cleaned up in the processing. And I think I've got another one there that shows yes, this one shows the some of the images, how they look after they've been corrected for the bit error or transmission errors. Now, the transmission errors creep into the whole system just by the fact that this is information that's transmitted over very large distances with equipment that is subject to noise. You also find that I'll have to read this out, so just excuse me a moment. I just want to get this correct. Okay, the communications link between the Viking orbiter spacecraft and the receiving stations on Earth did not use error-correcting encoding, and random errors found their way into the data stream as bit errors. If these transmission errors were in the high bits, they resulted in bright or dark pixels. Now, they're quite noticeable in the previous image that we had a look at. If they were in the low bits, the resulting incorrect picture elements were not so easy to detect. And it is easy to pick out in those images where you have the prominent bit error noise, because you see those dark and bright pixels, but that's not all the noise there is in those images. And so we have a lot of the other noise that's really not apparent because it doesn't stand out. It's not different or that different in contrast to the image itself. Now, these errors were corrected for by replacing any value that differed from its neighbours by more than a specified value with the average of its nearest neighbours. This is how they've actually smoothed the image to remove that noise, and we see the result of that here. They also used a similar sort of process to remove the roseau, although if you look carefully you might just be able to see a slightly darker greyer area where the roseau was in the original image. Now, one of the most important things to realise from this is just it's almost impossible to tell just how much noise was originally in the images, but chances are it was fairly high. And so when we're talking about very fine detail, we have no way of knowing whether or not the data that is in the image that we're looking at is just something that the computer has put in as a result of its own error-correcting algorithms, or whether it's something that's actual, it's a feature that is actually there in the planet, and information that is true, so to speak. Can I just have the next one?
That seems to be
Oh, that's it, is it? Okay, I thought I had another one, but obviously I've taken that one out. Now, some of the original Cydonia image work was done by computer technicians who were contracted to JPL, DiPietro and Molinar, and they wrote, or a book has been written about their work and so on, and they actually invented all these processes for trying to look more closely, specifically at the face on Mars in the Cydonia region. Their original work was done on the original NASA tapes, but the NASA tapes were never originally designed for the sort of processing, image processing that we do today in our computers. They were meant to be analysed in hard copy prints rather than having analysis done directly on the electronic data. This is something that seems to have escaped an awful lot of the researchers. When they have used the electronic data, they've actually had to modify it for use in modern computer image processing packages. So we've got a whole host of errors and processing artefacts creeping into our work as we go. The original electronic enlargements that they took of the face were full of transmission errors, lacked contrast, and had poor resolution. And this is one of the most important points, because I've often heard people quote that they've been able to, or they've talked about features that they've seen in these images that are actually smaller than the resolution of the original cameras. Now, it completely escapes me how you can talk about having teeth in the face that are smaller than the resolution of the original image. You just can't get down to that sort of detail. They actually developed a whole new technique that they called SPIT to enhance their images. They increased the resolution 9-fold, meaning they zoomed in on the images 9-fold before they actually started to play around with it. They stretched the grayscales of the image because Mars actually is quite a low contrast planet. It doesn't have, it's much darker than the Earth. For a start, it's much further away from the Sun, and it doesn't have a high contrast surface such as the Earth has. So the images from Mars don't have to be conveyed to us within the full range of what we would normally consider grayscales from 1 to 255. Most of the information that we need can be conveyed in 80 grayscales or so. But what they actually did, they had to stretch the grayscales of the image so they could enhance the contrast and hopefully bring up some finer detail. The original interpolation, the program interpolated the grayscale levels between adjacent pixels of the original image and rendered sharper edge definition. This produced a much cleaner image with better contrast, but was achieved at the expense of smoothing and massaging the data. So we've already had them increase the resolution 9-fold, which means that they trick themselves into thinking they can see information at much smaller resolutions than the original camera, which was a big mistake. As far as I've been able to tell, any subsequent image work has been done on the massaged images from DiPietro and Molinar, including the work done by Mark Carlotto. And there's been a lot of discussion on the internet about Mark Carlotto's work, and I'm not going to get into a discussion on his work here today because I don't think it's really relevant to the lessons that we can learn from all of this. But some of the interesting things that people tried to do with Cydonia data was by running it through fractal analysis. So they converted it to a fractal image. I don't know if any of you understand about what a fractal is. Hands up if anybody knows. Well, we've got a few people. For those that don't know, basically, if you've seen images of the Mandelbrot set, and is everybody familiar with the Mandelbrot set? Well, that's a fractal, and it's a mathematical sort of pattern that makes all the... it's very closely allied with chaos theory. But what they believe is that if you take an image and you convert it into a fractal, that you will actually be able to pick up patterns that reflect the way nature actually works. Well, I think that personally this is highly spurious, but all you're doing is introducing more noise into your data. But anyway, a lot of people have done this, and they use this fractal analysis on the images, and they use that as part of their, increasing the resolution of the images. Now, I don't believe that there's anything wrong with doing this if you just want to make better looking images. In fact, I have often used fractal imager myself to increase resolution in images. But it will give you a low resolution image, and it effectively joins the dots in your picture and makes the whole thing look smoother. But in doing so, it has generated its own information. It has interpolated what it thinks should be between the dots. And sure, you'll get something that looks like it's got lots of detail in it, but it's all pure invention. And you can't really use that sort of thing for doing proper scientific work. It makes images look very pretty, but there's no scientific value in it whatsoever. I do this myself at work. And much of the fine detail that is apparent in these images was never there in the originals. It has been introduced as a result of image processing. It should come as no surprise if a lot of this information then appears artificial, because that's precisely what it is. It's artificially generated in a computer. This explains, I think, one of the big differences between the reactions that you have with people such as Richard Hoagland's team and the people who are far more cautious working at JPL. They looked at the face and said, well, this is really interesting, but we'll wait for high resolution images, while Richard Hoagland and his team got stuck in and processed away and started to see all sorts of detail in images, started measuring angles and talking about angles far more accurately measured than could ever possibly have been done on the original images, and making all sorts of pronouncements about artificiality. Just can't do that. It's just...
Why not?
Why not? Because the information was never there in the original images. You've interpolated it. You've invented it yourself. You've made up your own evidence, and then you know...
What's to say that that image you just put on there was just made up, and what you're telling us is completely rubbish anyway?
Well, I'm sorry, what do you mean? That the Mars Global Surveyor images was made up?
How do we know that's the Mars Global Surveyor image? The Richard Hoagland's work is quite extensive and quite in-depth.
Well, it appears to be on the surface, certainly.
But talking with over 9 years worth of experience at the United Nations with a support of a team of scientists across the globe, how can you just put that down? I think maybe, with respect to your 22 years of experience and research, I think there's truth has a vibration, and what you're telling me just doesn't ring.
You don't believe that you can interpolate data?
We all know with computer technology you can fuzz up images. We all know that, it's not... Doctoring images is
it's done every day,
everyone.
Yes.
Yeah. But we're talking about mathematics.
Yes.
And angles.
Yes.
That relate to monuments that are both not only on Mars, but also here.
Yes, but when you start talking, you're starting to talk about this topology business and angles and things. Now, the angles that they measured on the Mars features were not measured from the original Viking images. They were measured from these processed up, with zoomed in and subject to fractal analysis and all sorts of bits and pieces that entered into the data that was never there originally. And so when you're looking at the angles of these things, you can't measure those angles as accurately as they maintain, because the resolution was never there in the original images. So, you know...
But how do we know that what you're saying there is right?
Because the original images had a particular resolution, and they're talking in terms that couldn't possibly be measured with the original...
Do you have some, like, photocopies? Do you have some pictures of what you're saying is right? Some evidence of what you're saying is right?
Well, I've shown you some pictures that show...
How do we know that's, you know...
How do we know that...
How do we know that's real, what you've just shown us?
Real from what term, from what perspective?
Real evidence. How can you try and dissuade the public, you know, from an idea that's backed up by a lot of scientific teams overseas and around the world of Richard Hoagland's analysis?
Very few scientists would back up what Richard Hoagland has to say. And I know he has a lot of people that he claims support his arguments, but most of them are talking outside the topic of expertise. And you find that, you know, if you go to JPL and ask anybody there, they won't back up what Richard Hoagland's team says about the images. I mean, these are the people that are really trained to look at planetary images. They're trained in the interpretation of this data. They know the limitations of the equipment. They're not playing around with images that have been fudged and massaged and smoothed and, you know, beyond almost all recognition of the originals. And this is the mistake that is made and overlooked by a lot of people like Stanley McDaniel, for example, who might be fine when he's talking about philosophy. But when he starts talking about the likelihood of certain things you know, being artificial or natural, he's really talking outside of his field of expertise. And, yes?
Excuse me, Claire. Sorry if I speak in simplistic terms. I'm not into photography and analysis and things like that. But when we had the original shot, it had all those rizos and all those little imperfections, if I can call them that, and they were removed?
They were removed through processing,
okay,
yes.
What were they replaced with?
They were replaced with the computer's interpolation between the grayscales. So what it basically did was it said anything that's above or below a particular grayscale value, ignore that and replace it with this value.
Okay, so the computer guessed what that was and replaced it with
That's right. That's right, but really it's a hole in the data, and we've just taken the best guess as to what's there.
So isn't that the same thing as that what you're saying, that it's been replaced by something that's not really there, it's just a computer guess?
Yes. But then you can't actually make a lot of these statements that are being made based on this information, given the amount of noise that was in the original images.
But what about pyramidal forms which are 90 degrees?
But they're not necessarily 90 degrees. And this is the point that I'm making, that you couldn't make those sorts of measurements on the original data because the resolution wasn't high enough. All of that has been done on these images that are being processed beyond all recognition. So really you're talking about, you know, measurements of far, you know, there should be enormous error bars on all those measurements. And when you look at the data that they put up, there's never an error bar on it. I mean, they can't even determine whether they're talking about 19.5 or 19.47 degrees. Now, yet they place all sorts of cosmic significance on this. Now, you know, I don't know of a cosmically significant number that would have such a large margin of error built into it. It's really nonsense. Yes?
Just to clarify a point or two about what you've been saying, I understand very well what you've been saying about fractals, and I understand that very well, and I think probably most people do. But when you're talking about angles, which are really a geometric feature,
yes,
it's because of the angle which the photograph, the projection, which the photograph was taken of the surface, or is this because of some other reason that you're talking about? For instance, has anybody measured the angles now from the latest photographs and compared them with the angles which were originally obtained, just to see what the difference was?
I don't know that anybody actually has, and I certainly haven't done this myself. But I think if we have a good look, and we might put back that original image, if we could, just put up the original, the higher resolution one. So that was the darker grey one, 070, no, not that one, sorry, the original Viking one, the 070A13, I think it is. This was the highest resolution image.
Yes?
No, sorry. It's the big picture where Cydonia, of the whole region, and the face is just this tiny little thing in it.
Not that one.
No, sorry, I'm all hooked up here. It's that dark grey one, I think. You'll find.
No, that was the one that I said I did before.
Oh, was it?
Yeah.
Oh, no, there's another one. Shows the big picture. That's it. That's the one. Thank you. Okay, so if we have a look at this again, this was the highest resolution Viking image taken of the region. And this had a resolution of 43 metres. So the camera didn't actually record any data that was, or anything on the surface that was smaller than 43 metres across. The latest image, the Mars Global Surveyor one, the MGS one, has a resolution of 4.3 metres. So we basically now have the opportunity to look at this thing with 10 times magnification on this. But taking this image, blowing it up 10 times doesn't give you anywhere near the same sort of resolution that we get in this particular image. And I think that that's quite clear when we see the best, or compare the best image that anybody's been able to get of the face, taken from the from the Viking things, and all you ever see are just very large sort of blobby bits. There's no fine detail there at all. Whereas in the Global Surveyor one, you can see when you look at the eye socket area here, you can see that there's no actual carving there. It actually is a crater. We can see what appear to be hydrothermal vents in the nose, but you can see that the nose isn't in the centre of the face. The centre of the face is, I probably shouldn't do that. The centre of the face runs down here, but there's not that bilateral symmetry that they talked about. You know, you can't actually see symmetry in the facial features at all. There's no symmetry between the sides of the face with the mouth. The nose is actually over to one side of the face, it's not in the centre. And there's no real eye socket at all on the other side of the face. So that symmetry that they maintained was, you know, absolute proof of the artificiality of this thing. When we see the high resolution image, it's just not there. That symmetry just disappears. Now, one of the important points that I wanted to make about all of this is that these same people are using exactly the same techniques again to look at what they call lunar anomalies. And they've basically given up on Mars now because they've realised that you know, all the things they've been saying for the last 10 or 15 years are actually wrong. So they've turned their attention to the moon, and they're going through exactly the same processes with lunar images. And I've seen pictures put up on websites and so on by Richard Hoagland and some of the other researchers associated with him, where they've taken images, Clementine images and lunar orbiter images, and they've blown them way out of proportion, and they're talking about being able to see structure in objects that are only 1 or 2 pixels across. Now, you can't see structure in a pixel, but that's exactly what they claim to do. Yes?
What is the resolution of the images they're taking of the lunar surface?
It would vary according to the height of the orbiter, and sometimes you can get down to some of the more recent images taken with Clementine. You actually have some quite high resolution images. Off the top of my head, I can't really remember exactly what the resolution is, but it's really quite high, probably less than 10 metres. With some of the other earlier Apollo images, of course, which is where they're doing a lot of their work, they're doing on the Apollo orbiter images. I mean, this is, once again, they're taking it from the old Vidicon camera data. They're not using the latest Clementine data, which is specifically, you know, the information is already in a format that's readily acceptable for our modern day computer processing. So they really haven't learnt the lessons. They're going back to the old data. Sometimes they're even doing it by scanning in hard copy images. So they take a flatbed scanner and they get a NASA photo and they scan it in at 600, DPI, which is what your average commercial scanner will scan at, and then they boost it up in a program like Photoshop, and everything else is pure interpolation. And yet, there's a whole host of analysis supposedly being done on these images, and the internet is full of this stuff, literally full of it, and all sorts of weird and wonderful claims being made about it. We have claims about there being glass domes on the moon and buildings, and I've even heard of one guy who maintains that he's able to see graffiti on crater walls. Now, these people take all of this seriously, and they look at these images, and I've seen their images. They usually convert the things to JPEGs, so they're full of all sorts of artefacts, JPEG artefacts, because they're using a high compression image type, and a whole host of information is lost. And there's all sorts of claims being made based on this sort of supposed research. And no scientist worth his salt would be caught dead doing that sort of stuff.
Is it the same technology as the spy satellites? Because they're pretty good, aren't they?
Yes, but they're designed for a different purpose. And the other thing with the spy, I've had this put to me before, that with the spy satellites, they supposedly can read a newspaper or read your car number plate from orbit and all that sort of stuff. Well, I don't quite know that I believe all of that, but I know that it has been, they've used fractal analysis to look for, tanks in the desert sands of Iraq and so on. And I've had that thrown up to me and said, well, if you can use fractal analysis to identify tanks in Iraq, why can't you use fractal analysis to identify artificial structures on Mars? And the simple reason is that you know what a tank looks like to begin with, and so you can put in a pattern for a tank and say, this is the fractal pattern for a tank. Go look for this particular mathematical pattern in the data. And when you find it, then we've found our tank. But we don't know what anything on Mars or the Moon actually looks like. We can't input a data pattern and say, look for this pattern in the data. So that's a completely spurious sort of argument. And the spy satellite technology is not what NASA uses for these planetary images. Although with the Clementine was a military satellite. But its images are freely available now. Anybody that wishes to can get hold of the Clementine data. It's available over the internet. I think you can even buy it on CD or something now. Yes.
Just on that, please. Has there ever been an official explanation as to why a military satellite is orbiting the moon?
I think they wanted to get more data about it. The moon has an extremely strategical value, has an extremely high strategical value. And, you know, they want to map the surface of the moon as accurately as possible. And believe it or not, even with all the missions that we have sent to the moon, we haven't completely mapped the surface of the moon. And there are still areas that are subject to, you know, great holes still in our mapping of the moon, such that amateur astronomers can still be used to fill in the data.
They haven't done the dark side, have they?
Sorry?
They haven't done the dark side, so I mean...
Well, the far side of the moon. Oh yes, we've had, every time an orbit has been around there, it's been as much around the dark or the far side as it has the near side. But
now that's what I thought these recent things were, to do that side.
Well, we really needed to get a better look, because the technique that we now have the technology to be able to hold that data in storage, whereas before we couldn't necessarily transmit the images back
From the other side.
From the other side. But now, of course, we have much improved technology on all of that, so we can store that data and transmit it when it comes back. But yeah, I can't see why the military wouldn't want to image the moon. I think that that would make enormous sense.
But why?
Why?
Were a military strategic for what?
Well, if you can put up, say, in terms of an SDI sort of installation, the moon would be a very useful place to have an STI base. It's also extremely valuable for communications, and would be quite a few other research values to the moon. But I don't believe that the military would necessarily be more interested in the more esoteric research things. But then a whole host of other technologies usually spin off from space-related technologies and developments. How are we going for time? I won't spend too much longer on this, but I would like to talk about some of the things that, the lessons that we can extract from all of this and relate it to work that we can do on images with UFO photos, because I know that there are an awful lot of people out there now who have the technology sitting in their homes to take images of UFOs. You know, we've looked at some of the video footage that's been around now. People are taking still photos. You can download this stuff off the internet, so it's all over the place. And people have the application sitting on their hardware at home, and they start fooling around with image analysis. And I know quite a few people who are making the mistake of using fractal imaging to look at UFO photos. And they're falling into the same sort of trap that the Cydonia images or Cydonia researchers fell into, where they're generating data and then researching, you know, the data that they've generated, rather than looking at what is actually there in their original image data. So I've just listed a few little lessons here. I think the most obvious is that pictures can be deceptive and things are not always as they appear. It requires a special understanding of the limits and appropriate applications of your technology to make an educated interpretation of your data. Image interpretation requires a thorough knowledge and understanding of the techniques involved in any processing or enhancement the image undergoes, in addition to taking into account the peculiarities of the instrument with which the image was acquired. And this is something that most people don't do. This applies equally well to photographs or movies taken with ordinary cameras or video and movie cameras. The second lesson is that you cannot extract more information from your data or image than is present in the original. There is no additional data hidden between the pixels of any image. And I've had people say that to me. You know, what's wrong with boosting up the resolution of the image? You know, by in a program called like Photoshop or something like that, where you just tell it to increase the image size from 100 pixels across to 1,000 pixels across. You know, what is wrong with that? Well, what's wrong with that is that you are asking the computer to fill in all that additional data, and it's just guessing at it. And then you're taking that, you know, data and applying your own sort of processes and things to it. You're analysing data that was never there in the first place. There is no data recorded between the pixels. And there is no data recorded for something 10 metres across in an image with a resolution of 43 metres. Simply using a processing algorithm to boost the resolution does not extract more data from the original data set. It employs pure interpolation and introduces processing artefacts which do not necessarily represent anything real. This means that the more processing an image is subjected to, the less reliable the information it contains becomes. This is an important point to bear in mind when looking at computer enhancements of UFO photos. I know of several people who convert photos to fractals for analysis. This process is probably the most dangerous of them all, as it relies on the software's ability to impose certain mathematical patterns on a data set. This generates even more spurious artefacts than simple interpolation. It is one thing to ask a computer to identify the tank in the desert sand, and another to ask it to interpret geological formations on other planets, or even, dare I say it, flying saucers. After all, we know what the tank looks like to begin with, and I made that point before. Anybody with a computer and the right software can process an image, but that does not make that person qualified to interpret the image. And I'd like to make a point here by comparing the use of a screwdriver and a wrench, because both of them are quite useful tools within their design parameters, but you cannot expect to undo a screw with a wrench. But in many respects, this is what a lot of people are doing. They're applying the wrong tool or an inappropriate technology to their research. The final and probably most important lesson concerns the power of belief over the rational mind. A whole mythology has sprung up around Cydonia, based on what was always very tenuous evidence, a couple of very poor quality, low resolution images. Otherwise intelligent and rational people wanted the features of Cydonia to be artificial so much that they manufactured their own evidence and then forgot that they had made it. Worse still, they branded anyone who dared to raise a dissenting voice as a debunker or part of a conspiracy to hide the truth. Sometimes there is no conspiracy. Sometimes the Sphinx is a geological formation, and its real riddle is how we could ever have ignored everyone and everything that told us so. And I think the most important lesson here is about when you start looking at an image or at any particular data set, and you start trying to find evidence within it to support your belief system. When you do that, you're not conducting science. You know, you're deceiving yourself. And I think that this is something that we as UFO researchers really have to be very careful of. That so often we hear people say they're so convinced that we're being visited by ET that, you know, they ignore any evidence that suggests otherwise. And we've probably all heard of all the conspiracy theories that have been around. And, you know, one of the most prominent earlier this year was the supposed conspiracy within NASA, although I don't know how you could get all those scientists to be involved in anything like that. The scientists that I know would never commit to anything like that. You just couldn't get them to do that. There's also a lesson, I think, in consulting with and listening to those people who are in a position to make educated identifications of things. And I'd just like to finish up with what I finished up with here in my paper, and that is that just a little word about that video program, UFOs, the best evidence ever caught on tape. there was an awful lot of video footage included in that showed nothing more than lights in the sky. In particular, I noticed the Mexican videos taken at the time of the solar eclipse. That was back in 1991, I think it was. I hadn't actually seen these videos until that program was shown on TV the other week, or a couple of weeks ago. And the first thing that I noticed when it came to those eclipse videos was that, they showed the sun, and then they panned across to this bright object in the sky nearby the sun. Now, to me, it was immediately apparent that it was Venus. No question in my mind whatsoever. And yet, they don't seem to have even consulted with an astronomer as to what this object was likely to have been. Yes?
Was it Venus that passed in between the helicopters?
No, I'm not saying that that was, but certainly
There were
in
video cameras.
yes,
18.
yes,
From
but
all around.
and over a large area. Now, the fact that certainly the object that they concentrated on most in that particular video sequence was definitely Venus. Now, this was seen over an area from cities as wide apart as 80 miles, I think they said, or 80 kilometres. I mean, that's a pretty broad area. This object had to be extremely high up, and it was high up. It was Venus. It was millions of kilometres away.
It passed behind a building.
But that's not the same object.
Video there.
That was a different video.
I think it's
I talked to
Yes,
places in
yes.
Australia that followed the eclipse, and they were on the Yucatan Peninsula, and they also had a live video feed filming the eclipse in Mexico City live, and they had no doubt at all that the image on it was actually Venus, and they had no idea that people were calling it the UFO.
No.
Until Larry Elders and company started doing the whole affair as sort of an eclipse UFO.
Yes, and this is one of the really sad things, that this stuff is frequently being touted around as, well, it was being touted as the best evidence ever caught on tape. Now, there's much better evidence around, and it scares me that the people that put this thing together, and obviously the researchers that have been collecting this stuff, never bothered to consult with an astronomer about a light in the sky. And I know that this doesn't always happen, but it happens often enough. Yes, Martin?
With regard to that particular one, I do believe in the early 90s that was recognised that Venus was discussed really in the UFO context.
Yes, but it was still put in that video, and that does worry me, because obviously there are a lot of people that either don't care whether or not it's Venus, or they just never bothered to research it properly. Anyway, as I said, I really do think that is one of the scariest aspects of that. And I would hope that, we do draw a few lessons from this that we can apply to UFO research, and particularly to photographic and video analysis, because there are definitely lessons to be learned there as regards to trying to get more information out of an image than is really there. So thanks a lot for your indulgence. I'll take a few questions if you've got some. Yes?
I've just recently read a book by Carl Sagan.
Yes?
He published it in '88, debunking...
Can you please speak up?
Yes, I recently read a book by Carl Sagan, published in '88, where he debunks the paranormal and also UFOs. Now, did he change his attitude just before he died? And you, as an astronomer, what is your attitude? Do you?
Well, I'm certainly not a debunker. I am sceptical. I'm proud to call myself sceptical, because I think that you need to be sceptical. If you're not sceptical of things that people tell you or evidence that's put up in front of you, then you're not a researcher. You've got to question things. And I mean, let's face it, there are an awful lot of hoaxes out there. So unless you're prepared to be sceptical, you might as well give up doing research. And you can't just accept every report of a light in the sky as being a UFO. And I think that I can't speak for Carl Sagan, but certainly as far as I'm aware, he never actually changed his mind. He was always very sceptical, but within the realms of good taste, shall we say, unlike somebody like Philip Klass, for example, who I think is purely a debunker. But I certainly had the greatest respect for Carl Sagan. He was always an inspiration to me, and he never doubted for a moment that there was life out there. He just doubted whether it was visiting us. And I think that, you know, that's a sensible sort of approach to take, and he was actually quite a moderate voice by comparison to a lot of other people. But from my own perspective, I have seen things that I can't explain. I've experienced things that I can't explain. So I definitely don't doubt that there is a phenomenon at work. I don't necessarily think it's extraterrestrial. I would certainly love to see evidence that convinces me that it is, but that's certainly not my feeling at the moment. But I certainly think that there is a phenomenon at work here, and that's my own particular stance. Yes?
Yeah, Claire, one of the most interesting things about this, I think, is the psychological aspects of it. I mean, the face on Mars is sort of only the latest version of the canals on Mars, or the face of Jesus. And
Exactly.
sort of stuff, you know.
Yes.
I'm interested in a psychologist's sort of interpretation of this desperate need to see more into things and
Well, I'm not a psychologist, so I can't sort of speak on that, but from my own sort of observations of the whole thing, I had an interesting discussion with my director through the week. We've been running a program in our planetarium on the planet Mars, and we feature a lot of images. Some of them are Viking images, and more recently we've been using some of the latest global surveyor images. And he made an interesting comment to me through the week. He said, "Oh, have you noticed that in that image of the sand dunes of Mars that there's the figure of a seated man with a beard?" And I said, "What?" And he said, no, I'm serious. You have a look at that image that we use of the sand dunes, and you know, you can see the figure of a seated man in it. And I said, "You're not going to tell me now that you think you can see this gigantic sculpture hundreds of kilometres across, do you?" And he said, No, I'm not saying that it's a sculpture, but we went and we had a look at this particular image, and yes, you know, once it was pointed out to me, I could then see this shape. And I think that this is something that human beings do very well. There was recently an interesting program on quantum on the face, and the first program there talked a lot about how we recognise faces. And I think that probably has a lot of pertinence to our identification of the maser on Mars as a face, because it talked about us recognising people on the basis of 3 points. And when we look at a face, we make the decision as to whether or not we recognise it as a face just based on 3 points. And I think that that's probably the situation with the face on Mars. The human ability to recognise the familiar in the unfamiliar is really very ingrained, and it's how we operate and navigate our way around the world. So we shouldn't be surprised that we see all these sort of things in geological formations.
And in the moon?
And in the moon too, yes. Okay, I think we'll have to end there.
I'm sorry. Thank you very much, Claire. Oh, right. Right, John Ockertell, as I was saying, is our next speaker. Could everyone take their seats, please, because we need to really move this afternoon. We're very, very much over time. Stamp on the cigarettes, put the coffee out. Do whatever you want, but get back here, please, now. What's PRA?
Phenomena Research Australia.
No, I don't know.
Is everyone ready to rock and roll? Good.